Okay, let's get this show on the road. And what I'd like to do is announce that the Twin Cities section is providing a tech talk or technical program about applying ISA/IEC 62443 to a unified namespace architecture. And the unified namespace, UNS for short, is quickly becoming the preferred architecture for digital transformation initiatives in manufacturing. However, there are concerns about how to maintain a robust cybersecurity posture. Most integrated control systems, otherwise known as ICS, use the so-called Purdue model. But what does this mean for a UNS architecture that's so new? And how do manufacturers connect new sources of data quickly and securely? This webinar will cover the basics of designing a UNS, how to architect the system and apply the 62443 standard to ensure it is secure. Rather than a hypothetical system, it will show a demonstration of a system that was designed for this purpose. Tonight's webinar is being presented by David Schultz, who's a principal consultant with Spruik Technologies. Spruik Technologies. He works with manufacturers to help them develop and execute strategies for their digital transformation and asset management initiatives. He has over 25 years of automation and process control experience across many market verticals with a focus on continuous and batch processing. He's the director-elect for the SMIIoT Division of ISA and serves on several technical committees. He is also a member of the Society of Maintenance and Reliability Professionals, known as SMRP, and the Project Management Institute, also known as PMI. So while you are all here virtually, let's welcome Dave to our Twin Cities section. And thank you, Dave, for doing the presentation tonight.
Yeah, it's my pleasure. As you're reading that, I'm like going, wow, this guy sounds pretty smart. And then I realized, oh, wait, he's talking about me. So you can always make things sound pretty good on paper if you really want to. So thank you for the opportunity to come in and present. There's been a lot of conversation around, a unified namespace, how to secure a unified namespace, going back and forth. And as a systems integrator, I get involved in a lot of these types of conversations of, as we put in this modern architecture, how do we ensure that we can keep it secure? Because one of the things we learned during COVID now is everybody's now moving off site. We have remote access to data, and it's giving a lot of people pause. And one of the features of the Industry 4.0 and the digital transformation that's going around or going along with that is we're now getting more and more data that is being sent to places that it hasn't previously been sent before. And wow, that's creating a whole lot of heartburn. So how do we, like I said earlier, how do we make sure that we keep all this secure and keep the bad actors out, but the data flowing as easily as we can? So before we get started, I just want to preface this that I am not an expert on 62443 standard. I would be hard pressed to even say that I'm a practitioner of it in a formal sense. That said, I'm well aware of the things that need to go involved or that are involved in securing an industrial control system. And I want to make sure that we're providing this in the framework of where we're going with that. So just real fast, an agenda slide. So we're going to go over a little bit of a definition just so we're all on the same page as far as what a unified namespace is, and then understanding how we go ahead and architect something like that. I'm going to walk through the development of what is involved in a unified namespace. So once it gets defined, then how do we actually develop something like a unified namespace? And then finally, what is the architecture? What are some of the sort of the rules of thumb that we want to follow when we start connecting all of this data? Because the idea is that we want to be able to take our intelligence and connect it to technology and make sure that as we exponentially create more of intelligence in a manufacturing organization, that can quickly and easily get consumed by other systems that might be of interest in it. So let's start off real fast in defining a unified namespace. So you've probably heard that the unified namespace, it is the single source of truth for all your data and events, and it follows the structure of your business. So what is meant by that? So when we talk about the single source of truth, most people will understand that, and we get into the old control system or a SCADA supervisory control and data acquisition. most people are aware of it in the context of your real-time data. So this is going to be all of your primary variables of your control system. So if you're, regardless of whatever it is that you're manufacturing, you will have automated equipment. There is a set point that is something should be operating at, and then there's the actual, what's the actual value that's there. And if you look at it over a series of time, this is where you get those trend charts, and that's that real-time data that you're getting. So from a unified namespace, that's very easily understood. But there's also transactions that occur within a manufacturing organization, as well as events. So transactions are, I have a new work order that's been created by my ERP, in this instance, your enterprise resource planning system. That is an event that has occurred, but then there's some data that needs to get pushed to other systems that are going to want to consume it. So in this example, it might be a manufacturing execution system that's, oh, there's a new work order, I need to schedule it, I need to get it brought into a line. So it's all of those events that occur that you want to make sure that you're capturing a semantic data model as it comes through through this UNS in a typically we're going to use an MQTT broker for this, but we want to use a publish and subscribe. So there's an event-driven architecture that follows through that. So again, single source of truth for all data and events. The structure of your business generally follows the equipment model as it's presented in the ISA 95 standard. And I have another slide that actually gives a quick highlight of what is meant by that. So all of the data and events that's moving through, they're creating these semantic data models of both real-time and events and transactions. We're getting all of that data presented in in following that equipment model. So the data that's presented, if it's down on a line or down at a cell, that information exists within a namespace that is relevant to that. So that's what I mean by creating these semantic data models and a hierarchy. And it's really what we're doing is creating this event-driven architecture, which is a fancy way of saying we want to use publish and subscribe technologies rather than a pull response. Most of the time, many control systems, or at least historically, have been on that pull response. If you think about, say, like an OPC server, that server, it's constantly pulling, say, a PLC that's sitting out on the line, and that PLC is responding with that data. In this case, we actually want to have the event, or excuse me, the PLC driving that event of there's new information that's available to you. I'm going to publish it so that there isn't that pull response. So that's what's meant by a pub sub or an event-driven architecture. So unified namespace, single source of truth for all your data and events. You want to follow the structure of your business, make sure the data exists in a contextualized framework, and then utilize an event-driven architecture. You put all those things together and you have a unified namespace. For the people that are familiar with ISA 95, this is that a typical, your hierarchy or your role-based equipment model. So you will hear people oftentimes talk about enterprise, site, area, line, and cell. Well, this actually comes from part 1 of that standard, although the equipment models are part of the part 2. This is where it's actually enumerated within the standard. It's one of the data models out of the 100 or so models in ISA 95 that are enumerated and spelled out. And most people will understand this. So information that exists at your enterprise. I talk about a new work order that was created within your ERP. Your ERP is probably a enterprise-based role within your equipment model. So you're going to have, say, new work order is going to be part of that. It's going to sit inside of that namespace that's associated with your enterprise. Versus say that I have a process cell that has a set point and there's some data that's coming from it of, I'm supposed to be operating at this temperature. Here's my set point. What is my actual temperature in real time? That information is going to exist down in, say, at the cell namespace in your PLC or your raw data. So these are all the namespaces that get created out of that. But as you start creating these hierarchical data models, you want to ensure that it matches the structure of your business, which generally speaking is based on your ISA 95 equipment models. It does not have to be enterprise, site, area, line, cell. It just needs to reflect the overall structure of your business. So if you have business units, if you have business groups, or other roles or organizations of your data structure, those are the types of things that you want to follow. So I know I've just thrown a whole bunch of stuff at you. Any questions so far on what we've covered? All right, perfect. People are very familiar with this model. It also comes from ISA Part 1 or ISA 95 Part 1, but this is what's affectionately known as the Purdue Enterprise Reference Architecture. The thing that is very different about these levels here is that Purdue is all around a function. Purdue focuses on connecting your data together and how you want to actually have your control systems, how the network and topology is set up. Because ideally, you want to be able to operate your level 1 equipment without having to be, without your level 2 system being there. And that's how you want to break this equipment out. So understand that the Purdue model is based on how you connect all your systems together and what the event horizon or time horizon is around that particular Purdue model or around that particular data. But your ISA 95 is more focused on the role-based of what is this equipment supposed to be doing. So it is the function of what it is. And then, of course, most people are familiar with 62443 as in the context of this Purdue model. There's nothing in 62443 that says you have to follow this. There's other things that are supposed to be guidelines, just most of the time. That's how we're familiar with it. So when people say Purdue is dead, they say ISA 95 is dead. In this new context, none of those statements are true. We're talking apples and oranges, two very different things. So I want to make sure that I'm really driving home the point that your equipment model, ISA 95, is all about its role, its function, where this is all around how you get all of your data connected together and how things should be connected. So like I said, if you have loss of connectivity, those systems, your plant will still be able to safely operate. So that's really the kind of the gist of what I'm getting there. So as we get into being systems integrators, most people are very familiar with this traditional model of how we integrate these systems. It's based on that Purdue model of here's where all of our events and how fast things are going to occur. Now I've put together and smudged some of those levels a little bit, so there's a little bit of hand waving, but I did that only so I could make a nice compact view. So you're going to have your devices, all your level 0, level 1 equipment's going to be sitting there at the bottom, and then they integrate point to point all the way through the rest of the system. So that you'll have, even though cloud isn't part of the ISA 95 standard, most often we'll have cloud sitting up at the top as we draw these out. Control systems are your HMI SCADA, that line or that delineation has been it's not as clear as it once was, but we'll call that as part of your control system. We introduced this concept of this workflow that we can now handle. Okay, if there's a downtime event that has occurred, so that's going to come from our CMMS system. There's a process and a procedure for how do we actually get, what are the steps that have to be taken to actually execute this particular order. But where this is important is that historically, when people have integrated these systems based on a Purdue model, it's, as I said earlier, it's this point-to-point integration where my PLC will connect to my SCADA, that'll connect into my MES, that'll connect into my ERP. And every time that there's new intelligence that's created, that has to be integrated all the way through the process. And one of the challenges of following that same architecture is that as you exponentially add in more and more intelligence, you're going to run out of time and you're going to run out of money before you actually get all of that data connected. So there needs to be a much faster way to get all this information shared across the organization. And that's where we get into the concept of a unified namespace. So typically in a unified namespace architecture, there's going to be an MQTT broker that is sitting in the middle, and there can be more than one. So keep in mind that there are namespaces that then make up the unified namespace, but we're going to use this broker and its event-driven architecture to start connecting all this data. So I can connect intelligence into this unified namespace, and that needs to reside, and that data needs to be modeled in a way that others can readily consume it. So as this, I'm a device, I know what intelligence I have, I'm going to present my intelligence in a way that is going to be meaningful to everything else, knowing that I'm the owner of this data, I know when my data changes. And that's how I'm going to present it, so that any one of these nodes in that ecosystem can consume from that data. So if there is a change in a PLC tag that is related to temperature, that might drive other operations. So for instance, out of my CRM, I might be utilizing some role-based maintenance where there's going to be 3 tags that, every time I see this, that means somebody needs to go do something. So as a CRM, or excuse me, as a, I'm sorry, not my CRM, my CMMS, for my maintenance system, that I know there's going to be a work order coming, I can actually get that scheduled. So rather than integrating that data in through my SCADA and then in through my CMMS, I'm actually going to have that information that's available to my CMMS to dynamically create that. And that's the whole idea behind this event-driven architecture, behind having nodes in an ecosystem. So earlier I was talking about ISA 95 and how that is role-based. That is all considered, or all concerned about what is the function of this particular data, what is the function of this system, in the context of what it is that I'm doing. And there's nothing within ISA 95 that says I can't do something like this. It's traditionally, we have understood that integration through that Purdue and the ISA 95. The point here is that you still have this data that's connected together. You still have an event-driven architecture. You still organize that data and that equipment, that role-based equipment hierarchy, so that the data resides at the place that it makes sense. But you're still going to publish and subscribe to all that information, so that other systems can consume that information, add in their intelligence, and publish that information back out in real time. So,
Question here, Dave.
yes, sir.
Playing a little devil's advocate here. As you mentioned, the Purdue reference model, and show the diagrams with the lower level hardware and then of course levels of hardware and levels of function. Can you give us some feel for whether our traditional PLC tags are fit into this unified namespace, or does this take over for tags-based system? Because they're all part of an event-driven architecture as well. So tell us what's different about UNS versus the old tag approach.
Yeah, so when you're in tags, if all of a sudden I come up with, from ISA, what is it, ISA 5, is that right? Where you have the naming convention for something. So it's your unit, and then it's a temperature indicating transmitter, and then it has a name to it. That's for all intents and purposes what a tag is. It's a T or a temp, 4283. Well, what does that actually mean? So you're going to have this raw namespace that is going to be your tags that you are going to consume, and you're going to create this semantic data model that's going to say, oh, that is my filler temperature in my third nozzle, so to speak. So that's where you're going to take that tag-based information, but you're going to convert that into a unified namespace, that semantic data model that gives you that information about it. And you're not only going to get its value, you're also going to get some units of measurement. You're going to have let's call it a smart tag that's associated with it. So as you start integrating with tags that exist in PLCs, this is really one of the easiest things to do, and that's another slide that I'll show you, is that we typically start off modeling assets because that's the most readily consumable and understood within a unified namespace. So that PLC tag is going to be based there. So no longer being that temp 6243 or whatever that number is that I made up earlier, that's now going to be my filler temperature in nozzle 6 in my overall hierarchy. So I'm in this plant, I'm in this area, and on this particular line, in this particular unit, and that's now going to be my temperature. And you'll understand what that is. So that exists in my historian. If I'm say that I'm a part of an MES that is doing recipe management, and I push that information, that's how that information is going to get exchanged. I'm not going to send it to that tag per se. I'm going to send it to my overall unified namespace model or data model that's associated with it. Does that answer the question? Yep, you're muted. So let's get into
That was very good. That was very good, Dave. I appreciate that for our listeners and future watchers.
Sure, absolutely. Yeah, that's the downside of watching this, after the fact. It's like you don't get a chance to answer the question, which is why you always want to attend these live. You can answer your questions. So how do we go about building it? And I think this is one of the biggest challenges that people have within a unified namespace architecture is, there's a great question that you asked, Tom, because pretty much everybody knows how to deal with tags. I know how to deal with tags in my PLC. I know how to deal with tags in my HMI or my SCADA. I know how to deal with tags in my historian. And then as I want to bring in my MES, I'm still working with tags. Well, I'm integrating all the way through there. So that's the first hurdle, is trying to understand what it is. But then it's also, well, there's events that are in this. So how do I actually do events within a unified namespace as well? Because it's a single source of truth for all my data. Okay, that's tags, we'll call it. But what about the events? And those are the things that we're going to break into. So I mentioned earlier that we want to create these semantic data models, and there are practitioners. So, I will give a shout out to 4.0 Solutions and Walker Reynolds. He's the person who has been at the forefront of developing a unified namespace. He actually has 3 different models that he creates. I've sort of extended that a little bit to where I have an asset model. I'm going to have an equipment model. I'm going to have a functional model, and then I'm going to have an informational model. So the easiest one to be understood is the asset. So we talked earlier about a particular a filler, or that we're going to start modeling sometimes in a utilities area, because this is where people really understand the concept of an asset. I have a compressor, and on that compressor, I have a motor. So those assets I'm now going to model as a motor. So rather than 6 tags that are associated with, okay, on a motor, I'm going to have my 3 voltages, I'm going to have my current, I'm going to have my speed, I'm going to have, maybe I have a vibration sensor on there. Rather than having that information that just exists disparately, I'm going to have those in a pump in a semantic data model that says, excuse me, I'm a motor. And then that motor is actually driving that compressor. And on that compressor, you're going to have my my inlet temperature, my outlet temperature. I'm going to have flows. I'm going to have pressures, all the other information that's there. So that's now another data model that's going to be created around that asset. So rather than looking at all of those various tags, we're going to create the asset model. In this case, I've used a motor and a compressor. I've used that one all the time. We also have equipment model. So as I mentioned earlier of the ISA 95 standard, this is role-based. So we're actually going to create models around our equipment. So maybe there's a filler model, and within that filler, there's going to be certain pieces of data that we want to ensure that we have for all of our role-based equipment. So one of a common metric that you're going to have in a filling equipment or on a line is you're going to be calculating OEE. So for all of our equipment-based equipment, that made a lot of sense. For all of our equipment-based data models that we create, I always want to have for calculating OEE, I want to know what's the state, what's my in feed, what's my out feed, what's my reject, and then what's the actual calculation of that OEE for that particular line. So that every time I have the concept of a line anywhere in my enterprise, I'm always going to have that type of information that's going to be included. That's that equipment-based data model that exists there. So with the functional data model, that's all around a calculation or an event. So the calculation, I mentioned OEE earlier. Well, every 60 seconds in many systems, I'm going to calculate OEE. So I'm going to take the line counters that I referenced earlier, and I'm now going to calculate what is my OEE based on that state, based on what that count is, and those 3 values that I get, so your availability, your performance, and your quality, and multiply those together and getting OEE, I'm now going to publish that back to that unified namespace so that on the line, not only do I get my raw counts, I can see what is the overall performance of the line. Maybe I'll have my from another system, I know what my product code is. I'm going to know what my work order is. That's all the information that goes in, to making this particular calculation. And then finally, there's the informational one. So this is, I'll commonly use these for, developing a screen. So one of the tricks that we often use is that rather than creating one HMI screen statically, that now if I have a different screen, I have to create a screen for every view, I can actually parameterize these, because I can use an information data model that I have created dynamically to populate that screen. The reason why this is important, remember, this is the single source of truth for data and events. I want to know what's the operator looking at on the screen. And if I'm historizing all that information, I can see exactly what was presented on that screen, because that's an event. I looked at a screen. And that's how you want to get that information captured in there. And so these are really the 4 semantic data models that are created. I'll actually have examples here, but real fast. Any questions on what it is we're trying to do here? All right, cool. So I referenced earlier, you notice I said compressor and I had motor. Well, there's a reason for that. So the asset model that I'll typically work with in creating a unified namespace, you can see on the screen, looking at that overall structure. So you can say I follow that my equipment, my role-based equipment model. So I have my enterprise, my site, the area that I'm in, and here's utilities. I'm in my compressors, and it now created a data model for my compressor that has my flow, my pressure, my temperature, my vibration on it. I also have a namespace that is for my motor. So that's that current, speed, and vibration that I have here. What I also demonstrate here, and the tool that I'm using to create all these screenshots is inductive automation, a product called Ignition. It is a, first and foremost, it's a SCADA platform, but because it connects to databases and has APIs, it gets used as a platform for our digital transformation and all of the. It's an IIoT platform, so we can create all that. I also take advantage of parameters, so I use tags for my dynamic data, and then I'll use parameters for what's the area, what's the site. I give some information around what's the manufacturer, what's the model of this particular compressor. I'll do the same thing with the motor as well, but I'm expanding on that to give you an idea of this is all the information that is now presented. So rather than just having all of those disparate tags, in a tag-based system, I can actually look at this data and know exactly what it is that I'm looking at. And honestly, if I expanded out that data even more, I'd actually see what my engineering units are, if I have mins and maxes, when's the last timestamp that, when's the last time that this tag updated, that type of thing. But this is an asset model. Most people are familiar with like OSI Pi. They have their asset framework, these types of things. That's exactly what it is we're doing here, which is why oftentimes we'll start with asset models. Then we get into the equipment models. So I referenced earlier, we have the enterprise set area line cell. Following that same role-based equipment model, we're going to have an enterprise site. We're in an area here, and this is where I'm now going to have a line-based UNS or a data model. So I referenced earlier, I'm going to have some OEE counts. So for every line type object that I have, the data that I want to ensure that I get is my in feed. I want to have my mode, which is what's the equipment supposed to be doing. I have an out feed. I also have what's my scheduled rate, which is when I schedule this product or schedule this production, how many should I assume I'm going to get, knowing there's going to be some downtime events. But then my standard rate, I know I should be able to do more. So I'm going to have that information. So the standard rate is how I'm going to actually calculate OEE. I want to know what is the actual state. I give it a state enumeration because one can mean something different for every system. So I want to know, okay, one means running in this particular context. I also have waste or reject. You'll also notice that there is a couple of there's a run OEE and a shift OEE and a work order. Those are functional namespaces that will get called out a little bit later. And you can see in the information on the right, that's where I have a cell. And on that particular cell, I also have, say, in feed and some state, but I also have a CMMS tag. That's another functional that actually is related to a work order that might exist in that particular case. And you can see that I also have CRM, ERP that exist in this data model. Those were actually each site themselves had that data space. So a little bit more of a challenge to understand. Any questions, thoughts, or comments on the equipment model that gets created? So now we get into the functional models. So I mentioned earlier that we're going to have a run OEE and a shift OEE. Well, this is a calculation that is occurring from there's an OEE engine that's running. So one of the MES tools that I use is my OEE. So because my line model has all of the information that I need, all of my OEE information becomes very easily because I can now parameterize the connectivity to what data do I need to consume, and it makes it very easy to replicate what I've done here. But I'm going to have a run OEE, which is based on when I started running this particular product code. So in this case, we're running RJ5000 on this particular line, and you can see all of the actual counts that are associated with the run. So it's not the raw count that's coming from the line, it's actually the counts of my in-feed, out-feed, and reject or waste that are associated with this particular product run, but I can also have my shift OEE that's available as well. Now, it doesn't have the context of the product code because it will, there are multiple product codes that are being written, but this is that functional based on there's a calculation that's going on. On the right, I mentioned earlier that there is that CMMS, that is a downtime event that in this particular case on my cell 1 that I need to clear the jam from the inlet of this cell. So my CMMS, in this case, I use a product called Upkeep. Their CMMS, I have an API call that returns a data set that I then enumerate, and you can get all the information of what is the downtime event that is occurring on this particular line, and it gives you that information. So because of this single source of truth for data and events, I can see I have a downtime event based on my state, and then I can also see, is there an active work order? And I can, in real time, see, oh, yeah, there's a work order number, and typically there's somebody that's assigned to it. So this is a functional model. You also have, so I've actually demonstrated what a downtime. You have material movement. So this is one of those I've received loading from I've received some new material into the plant, and I'm going to get things like lot information, how much of it was it, what's the product code, who brought that information, or who is our supplier for all this. So that information becomes in a data model that when that event occurs, that event is then published to a unified namespace. I can also get calibration. So this is, since we're part of ISA, our roots are the Instrument Society of America. When I calibrate an instrument, I can have now my the asset model that I'm using for all of my calibration that actually gives me information of as found, as left, who's the technician, the date, all that information then gets presented. So whenever these types of things occur, or there's a scale calibration, that functional model, that event is published to a unified namespace, and that's now readily consumable. So if all of a sudden I was looking back and we had where this becomes powerful is that if I have a quality issue, I can also look to see when's the last time that particular instrument or that scale was calibrated, and becomes very easy for you to access this information because it's all presented in a way that makes sense. And then, of course, we have the informational model. So I'll use this for HMI screens. I'll also use it for populating dashboards because it's it's easy to dynamically create those. I can also use those for reports. So you can see here on the left screen, I have a dashboard OEE. So I'm actually doing an OEE calculation in this case. I'm getting what my OEE and my APQ values are, and that information is then used on a particular screen. So if I'm on line 1 versus line 2, I can, as I'm viewing this information, I can have that data pointer, if you will, coming from line 2. It makes it very easy to calculate what's there. On the right side, that's actually it's a dynamically rendered screen, so that whenever an operator is working with a particular screen or looking at it, that is built at runtime, and so there's some scripting that's done that actually populates that data. The power of this is that you end up with the exact same data model, but you can also, as I mentioned earlier, exactly what the operator was looking at that time, because all this information is historized and it's now readily viewable of what was going on at a particular time of this event. So those are the 4 different data models, but that's how all this information gets put together. We start with modeling assets, we then model equipment, we get into the functions and the events, or calculations and events, and finally there's just information. How is this information presented back out? But these 4 different types of models, that's what make up a unified namespace, so that all my data, all my events are captured in a semantic data model, so that any event that occurs, that it can be readily understood. It's the real-time state of the business, if you will. So any questions about a UNS and how that gets put together?
Love the contextualization of data to become, like you say, information that can become the absolute truth. And so we need to rely on that. And I like the way this is going, Dave. I'll reserve any other comments until we get through the demo. And
we'll see what happens.
Yeah.
Yeah. Well, I should say this isn't a live demo. That's like, you never want to do a live demo. So I captured screenshots, of everything that's there. But with a little bit of hand waving, believe that that's exactly how I got this data. And if you don't believe me, I have this lab behind me, which is, I have a whole lot of equipment that actually provided me with that. So here's how you want to connect your intelligence to technology. So people are probably very familiar with the converged plant-wide Ethernet. My understanding of this diagram was that Rockwell and Cisco got together and they decided this is how we're going to apply 62443 to the Purdue reference architecture, and we're going to bring all this information together. And when I look at the screen, it is an eye chart, but it is their position that as you are connecting all of your systems together, through Ethernet, through the blue hose, as I call it, this is how you want to do it to make sure that you're maintaining the security of all of your data, that nothing can get in. And this is creating all your zones, all your conduits that is talked about within the 62443 standard of how the data flows. So I just wanted to present this so that people say, okay, now I understand what somebody is talking about. There is a variation that was put together by Energy Aspects, Tom, maybe you're familiar with this particular company. So this diagram here is taking that converged plant-wide Ethernet and distilling it down to something that's maybe a little more easily understood, but the idea is you're going to have your engineering, your technology, you're going to have any type of data systems, or all your plant level information. All that information is connected together, and how you actually want to segment everything out. So you're going to have all your VLANs and firewalls, and you can see all of the information that goes into how do we create that, taking the 62443 standard and applying it into a Purdue Enterprise Reference Architecture. When we take this same concept, but then we bring in the concept of a unified namespace, what you end up with is that we're still going to have all the Purdue Enterprise Reference Architecture levels that are associated with it, but we're going to extrapolate those utilizing the idea that, okay, this is my level 4 data. I still want to have that data segmented. I want to use VLANs. I still want to have all of the segments, but I'm going to take a look at it. This is my level 4 system. Here's how I'm going to apply it, so that the information that is created, so all of the intelligence that is created throughout the overall enterprise, I'm able to keep it secure, but I'm also able to get it to move a lot faster, a lot easier. So I'm still keeping the levels and the segments, but I'm approaching it from this is just level 3 data, and I'm going to bring that into the UNS. So I'm going to apply all these other, the standards that are to it, but I want to focus on the level of the data, not how all of it moves together. So it makes it a lot easier to to understand and digest of what's happening here. So rather than having all of the firewalls and the VLANs and that type of thing, we just want to look at it from what's a level of the data that's associated with it. So as we start connecting intelligence, we want to take a look at what are the minimum technical requirements. So as you start, we want to architect this event-driven architecture, and we want to utilize a unified namespace. As we start to pick technologies, what are the things that we want to look for? Well, first of all, you want it to be, it's open, lightweight, report by exception, and edge-driven. So open means that we play well with others. And that means that we no longer want to have this information or this data that you can no longer get. And I'm sure you've all run into situations where I can't access the data on this piece of equipment. The provider, the OEM, they've locked that down. I can't get at it. One of your minimum technical requirements for anything that you purchase in the future, it needs to be, you need to have that data open. I need to be able to get information out of that. So, gone are those days if you can't do it. And I also don't want to use any kind of proprietary standards for how I want to get all that data communicating. It needs to be open. I need to follow a standard, architecture, whether it's an API call or a SQL query, or utilizing, I mentioned earlier, MQTT. I want all that to be open. I don't want to have to pay for accessing my data. So it needs to be open. It needs to be lightweight. And that's where we get into, we want to minimize data on the wire. Remember, we're going to be exponentially adding the amount of data that's going to be published and consumed by the overall, by the enterprise. We don't want to bog down the overall technology. The network infrastructure in your plant, there's only so many ones and zeros that can go through that blue hose. We don't want to ensure that we're minimizing the amount of data there. So as you're doing this data exchange, you want to ensure that the data is a lightweight communication protocol. I mentioned earlier event-driven architecture. It's report by exception. You only want to present new information or new data when the data changes. And so I always liken this to when we go back to the family vacations, what's the most common question that is asked on a family vacation? Are we there yet? That is poll response, because there's no new information, but I'm still communicating. Are we there yet? No. Are we there yet? No. Are we there yet? No. Versus that report by exception, which is, hey kids, we're about 10 minutes from grandmother's house. Start collecting your stuff, put your shoes on. We'll be there soon. That's report by exception. There's new information, and it also means we need to act upon this new information. We're getting new information. That means we're going to have to do something with it, or chances are we will. And then finally, edge driven. And this means I talked earlier about, as the device, as the producer of this intelligence, I know what intelligence I have. I know how it should be presented. And I know what the overall architecture, what is my namespace? What should it look like? Because I know where I exist within the overall framework of the enterprise. If I were following that equipment model, I know where that information exists. So edge driven means that I should instantiate my connection. I should give you my data. I should give you the data in a way that is going to be most readily consumable by other systems. And so that's what's meant by the edge driven. So when you start looking at new equipment and new technologies, these are the minimum technical requirements that you want to have for all of the producers and consumers of the data. So there's the one aspect is how data is flowing back and forth, but I also want to have technology of how do I get everything connected. So one of the things that is powerful about using an event-driven architecture in this technology is that I can have client instantiated connections. So I talked earlier about how an OPC server will always do a poll response to the overall data. Well, in order for me for an OPC server to gain access to that PLC, I have to actually, the server itself is what instantiates that connection. Well, in this case, we want to actually have the client, we want to have that producer, that PLC, instantiating that connection. Which is completely opposite of whatever is, how we've traditionally done that. But the benefit of it is that if I'm now going from, say, my level 2 to my level 1 system, I no longer have to open a port, because now it's my client that is going to be pushing that data from that level 1 into the level 2. So it's client instantiated connections, but you don't want to open any inbound ports from a higher level. Clearly you're going to have open ports from a lower level, but generally speaking, and I'm going to wave some hands here, your lower level technology you want to keep most secure. So this is where you get into some inherently secure technology. You also want to have the concept of authentication, whether this is Active Directory or OAuth or any one of those. You want to ensure that there is a username and a password that is associated with authenticate who you are. What is your identity within the overall organization? So you want to apply that and ensure that as much of your technology as you can has some kind of authentication to where it can no longer access, or before it can actually connect to everything. So in the context of a broker, there's a username and a password that is associated with you actually making that connectivity, because there's also role-based connectivity on what you're then, as that particular user, as that identity of this data, what you're allowed to publish and what you're allowed to subscribe to, which gets you into the authorization. So once you've authenticated, now is what is it that you are allowed to do. So within the context of an MQTT broker, what are the topics that you can publish to? What are the topics that you can subscribe to? Can you publish? Can you subscribe? And then as a user on the other side, when I authenticate into a particular system, where it's SCADA or MES or ERP, what are the rules? What are the things that I'm allowed to do with that particular data? So you want to have that authorization in there as well. You always want to use encryption. So it's the data at rest, data in transit. So you always want to, in a very easy sense, you always want to encrypt all of your hard drives, or all your storage is encrypted. So if somebody physically gains access to that storage, they can't do anything with it. Or whenever you are communicating and it has data, or you have data that's in transit, you also want to utilize, say, TLS in this case, to where the data that's traversing that particular wire, that's also encrypted, so that if somebody would gain access to that network, they're not going to be able to gain access to that particular data. So you want to ensure that you're applying encryption in this case. Multi-factor authentication is part of that authentication authorization process. So any of my RDP, my remote desktop sessions that I create, anytime I access secure shell on these devices, I have, for my network, I have Active Directory, but I have to also use a multi-factor authentication. I can't access anything. And then finally, logging. You want to have a big data storage for logging, so that anytime there is an event or anything that's going on, that any type of information, anything, an event that occurs on that particular device, you want to make sure that you're getting that data logged. So not only do you want to have the open lightweight report by exception edge driven in the technology, you want to also apply, I want client instantiated connections, no inbound ports. I need to be able to use authentication with a multi-factor authorization. I would need to be able to encrypt it, and I also need to be able to have some kind of data logger, so I can go back in, and there's always that history and audit log, if you will, everything that's occurring. So those are the MTRs. Any questions on that? So what I've attempted to do in this architecture is that this is my lab in a simplistic, in the application that we're going to look at. So I have my internet that's, starting from the top left and coming all the way down. Imagine this is that I've now created my own enterprise, or my manufacturing site. So I'm going to have the internet. I'm going to come in through a firewall. I'm now going to have a router that, it's actually not a wireless router. It's just a non-antenna router. And then I'm going to create VLANs right away. So my VLAN 1, we'll consider that that's like the enterprise side of the business. So I'm going to have my application server that sits there. All the applications, there might be a SQL server, might have my there might be there could be all kinds of applications that are running there. This could be my Active Directory. This could be if I have a local based CRM or ERP. That type of information is now going to sit on the business side. And any port that I have coming into or that's open is either going to be on that VLAN 1. Actually, I don't have it represented here. There's the only inbound ports I have are sitting on a completely separate VLAN that nothing else talks to. So if you were to gain access, you're only going to be able to see that information. On the right side of this diagram, that's where you're going to get into that OT side of the business. There's no ports that are open to it. Anything that needs to get out to the internet is going to be going through, it's going to be an outbound instantiated only. So on my VLAN 4, that's going to be where I'm going to have an application server, where I'm going to have another domain controller for my authentication, or an Active Directory or some type of authentication service sitting there. Might have, again, another SQL server. And this is a point of conversation, that you could have that application server being a replica of your Active Directory, or your authorization, or your authentication server that's running on that enterprise side. And there's certainly arguments either way. For all intents and purposes, we're going to say it's isolated in this case. I have my SCADA system, my MES, and I have my data historian that sits there. I'm also going to have some, I have another switch that's now created some separate VLANs. So now when I go from my level 2 and level 3 systems down to my level 1 systems, where I actually have all the PLCs, I created yet another VLAN. There's also firewalls, so nothing can get in. So those firewalls are all closed. So I don't know if I can put on a pencil here, but I think I can get a laser pointer. Oh, look at that. So here in my actual environment, I have some equipment that is more modern, but then more often than not, I'm going to have some equipment that is I don't want, it's legacy. It's traditional equipment that has existed in my plant for a long time. So, we were talking earlier about tags. How do I gain access to, say, a Siemens or a Rockwell PLC that doesn't meet my minimum technical requirements? Well, in this case, I'm now going to have Ignition Edge, whether that's sitting in my Edge gateway or it's included in my Groove Epic. I can use my Ignition Edge and my transmission, where I can subscribe to all of those tags, and then I can consume that information and I can publish it into the higher levels. So what I'm doing here is using Ignition Edge, connecting in using its device driver. I can create my unified namespace, my asset model based on the tags that are here in my equipment model, and I can publish that information out. Or I can now use an easy, so getting back to my minimum technical requirements, I could decide I'm going to use Easy Automation. They have their Easy Logics that has Sparkplug. That's an MQTT. It's a specific payload that will publish right to, right from the device itself. So I don't have to use any kind of, say, Ignition Edge in this case. It supports my minimum technical requirements right away. Or the last piece I can use here is my Groove Rio, and there's a couple of ways I can get information out of it. I can either use its native Sparkplug publishing capabilities, or I can combine this Rio with my Epic that, with the Epic actually has two different network cards on it. So one's going to be sitting on my my control side, and the other one's going to be sitting in on my PLC side. To where now I can actually talk right to that PLC or talk right to that Groove Rio utilizing the Opto MMP. So there's several ways that I can get data out of there. But the point is that all of that information sits on its own control, on its own control VLAN, and there's nothing that's inbound to that information. I also have a Chariot's broker that's sitting here. So Chariot's one of the MQTT brokers. It's by Cirrus Link. So I'm also going to have a broker that's sitting down here. So this information, if it needs to, it can pass information back and forth. So if there's, one of the PLCs or one of my control systems needs to get that data, I'm now keeping that information isolated. That's all of that information that really exists at that control layer. I'm going to keep it there, and then only information that needs to get promoted into a different layer of the business will be that will occur either through this Ignition Edge that's running here on the gateway or the Ignition Edge that's running here on that Groove Epic. Now, this becomes part of a cybersecurity posture because there's a couple of different examples that I'll show you. One where I actually do open up a port down to this Edge gateway so that my SCADA system is actually going to be subscribing to this broker down here as well. That depends on your security posture if you're okay with doing that. Otherwise, you're going to have to take this data that exists here at this broker, and you're actually going to have to repackage it and then present it up higher. So that's what you're seeing here by the Ignition Edge and the Ignition Transmission that sits down at this layer. And then once that information is up here in my VLAN 4, that information can now be consumed. So I have a Canary historian that consumes that data because I also have another broker that's sitting here on my SCADA. My Ignition can consume it, my MES, which in this case is Sepasoft, and my Canary can all access that information. So by virtue of just me creating new intelligence here, it's now available to all these systems just by virtue of I've now connected it into my technology, into my MQTT. So did I explain this? Is this making sense to what I'm doing here so far? Okay. The point is that I got firewalls. There's no data or there's no inbound ports that are being opened. Everything is client instantiated. All of this is presenting itself up to higher levels. So let me get rid of my pointer and hopefully I can just click out. All right, I'm going to move this out of the way.
What are you using for a firewall device? Or what's an example of something it would be used in a system like this?
So when I say the firewall here, this is all software firewall. So on the Groove Epic, there is a firewall that comes with it to where that I can now determine what services are available on the various different, the control layer. So all of my level 4, other than getting information that I need to go in and do some, I need to access the development environment so I can just configurations for what I'm going to access. But anything that's controls related, those are all closed off. The group also has the ability to do some port forwarding. So that's one of the ways that I can gain access, is that I can interrogate this side of my Groove Epic. And then I can just say, okay, well, if it comes in on this particular port, we're now going to send it down to, say you have a Rockwell PLC, I can actually hit a port on the VLAN 4 side. So I'm on my 4 subnet. That will then use port forwarding. It's sort of like a reverse proxy, is sometimes they're called. On this one, I'm just utilizing, this is a Linux based product. I'm using utilizing UFW, so that all of the data that is being presented here, it's all closed off.
And
Go ahead.
also, Grant, as a shameless plug for what Dunwoody uses and what Paul Wieneman and I had in our recent industrial critical function security track, we had a sponsor of Fortinet, and they produce some good products that unfortunately they've also been tagged by CISA as having some vulnerabilities, but what doesn't? So it's a matter of being able to understand what the vulnerabilities are and working around them, or updating the firmware on if they have firmware and stuff like that. But Fortinet has some great industrial products that I would look at.
Yeah, so I'm using a software firewall. It absolutely could be a hardware firewall. The advantage of using a product like, say, Fortinet, and this is our position on the technology, is that you make it as easy to connect and get data moved around as you can, and then you utilize tools that have some kind of AI there, or something that's looking at the wire all the time to see what is the data that's moving around. And if I see something that, wow, that's unusual, I don't usually see that type of information coming from that particular source or going to that particular destination, I should probably check that out. So when I was talking earlier about how I have the system architected, I'd forgotten that I added in this slide. So this expands a little bit more of, here's my area broker, here's my site broker, where all this information is being presented. So that way, any information that is part of my packaging system, all of my various lines, all my lines can talk to each other, but they don't necessarily have to go to other parts of the business. So it's a good way of keeping everything segmented out there. But like I said, Siemens, I have to connect to with Ignition. My Easy Logics has Sparkplug. My Rio, I can either use Sparkplug, or I can take advantage of utilizing that with the Groove Epic. So the Rio is a remote I/O, as the name would suggest, and then in this case, the Epic would be the PAC, the programmable automation controller that utilizes. I can have a lot of different Rios out there. So there's some options that I've created here. So the first one is I'm now going to utilize my Alto 22. This is data as it comes from my Groove Epic. Within a Groove Epic, you can see that this uses a strategy. So what a strategy is that if you're familiar with doing PLC programming, this is the actual, what is the program that is running that I'm constantly going through and looking at what is the data. It gets called a strategy. So from that strategy, I can get all of my analog and all of my discrete data. So these are all the PLC tags that are coming from my right out of my my Epic, and I can present that into the this is now being consumed by that site broker, and this is what that data would look like. So the Epic that's sitting there, it has it's connected to other systems, and it's now publishing its data just right out using its native Sparkplug payload coming out of there. And this is what it would look like. So now we just have tags. We don't actually have the semantic data model. Line one, using the second option, is that we're actually going to use, instead of the strategy, we're now going to separate out. So I mentioned earlier that I have the Epic and the Rio that are both presenting information. So in this case, I can have all of those channels are just coming natively from the Epic. So rather than publishing its overall strategy, which includes everything, I'm now just going to give you the raw data that comes from that. And this is what the Rio looks like. But again, these are coming from the native, this is what it looks like at the site broker itself. Now, what's happening here, as I mentioned earlier, is that my RIO is actually publishing its information into the area broker. So just going up real fast, it's publishing its information here. I've actually opened a port for it to subscribe to that data. This becomes a posture of, am I okay with doing something like that? I am opening a port, but I'm opening up a very specific port that only gives me access to a data broker. So that just becomes a decision point there. But that's what it would look like, and that's why I mentioned that the SCADA connects to the area broker, that there is a port that is open. So in this case, so all my opto equipment is all on line 1. On my line 2, this is where I now have my my automation, my Easy Logics is now going to subscribe into my my area broker. And again, I'm also going to have my SCADA connect, same type of way, but that's what this information looks like. So I've now created intelligence down on my control layer. I'm presenting it into my area broker. And then, of course, my SCADA system is connecting to the area broker much the same way. The other option, and this is what I've done, is I actually now take advantage of the transmission that I have running on that edge gateway. So let me run back up here to the diagram. So now on this edge gateway, I actually have an Ignition Edge instance that's going to consume the data that's being presented from on this Chariot broker by my 2 spark plug supported devices. I'm going to model it, and then I'm going to present that information to the Ignition Edge that's sitting now on my Ignition system, that's part of my SCADA system. So now you can see that I have in my South Park plant, in my packaging area, I have line 1, which is going to be my RIO, and you can see that folder is sitting there that has those tags. And my line 2 is now my Easy Logics device. So, I have it all. It's basically the raw data that's coming from that line, but now I'm starting to put that information together in context. The advantage of doing this is that I don't have to open a port. The downside of this is that I now need another software license so I can consume that data right there on the device itself. Excuse me, from my VLAN 8, my control LAN, and then publish that into my SCADA. The next one is on line 3. So I'm using the same equipment here, but in this case, we're going to say that my Opto 22 and another application, this is sitting on line 3, that I'm going to use my Ignition Edge that has my Opto driver. So all the Opto, so my RIO and my Epic, I can now consume that information, but I can actually start creating data models from it. So you mentioned earlier about, Tom, about how do I take all of my tag data? So I'm actually mapping this. So I'm creating a binding to that raw tag. So when we looked here at that Opto, I'll let discrete and analog. Excuse me, I should have grabbed some water here. I'm now starting to create my semantic data model. So now in my filler, I have my filler is my RIO. I have filler nozzle 1 and filler nozzle 2. And then my main controller for my line is going to be my Epic. And you can see here that I have my, do I have an alert? So my discrete, my analog measurements that I'm getting, that's related to now alerts, a primary variable and a set point. The advantage to this is that, on my Ethernet 1, I'm connected to all of my plant floor equipment. On Ethernet 0, that's the one that's connected to the control system. I get the data modeled and present that up. And this is what it looks like, in this case on line 4. This is where I have my S7 1200. I'm using that same Ignition Edge. I'm creating an asset model of a particular motor. It connects to the site broker, so it's publishing that information, but the data gets modeled right away. So, and this would be just a standard, control algorithm coming off of a motor itself. And the models that I'm demonstrating here were that's what I happened to have on the S7 1200 for another demo that I was doing for somebody. So these are the various ways that you can start connecting all of the all that information together. So now trying to bring everything, all the way together, you can see here at my, my enterprise, my line 1, I'm now subscribing to all this information. I have all of my raw data that's coming from my assets. And then I also have my equipment model that's a part of this. One of the things I didn't show, these are some material movements. So I have material ins, and then I also have material out that's coming from there. But this is what a site UNS would look like. But you can see in this overall, putting everything together, I have asset models, I have equipment models, I have some functional models, and I have some informational models that are associated with everything that I've put together here. And then it's SOC, that's your standard operating conditions. So those are all the set points that are associated with it. That's bringing it all together. So any questions that you guys have?
Well, you guys know me, so I have a ton of questions, but I'm going to leave the floor open. So I'll let you guys squeeze some in. Okay. Oh, you got to unmute there, Grant.
So is there any synergy between, especially the modern controllers and all of these systems, where you can access the tags and not have to enter stuff in? And with the legacy systems, is there any synergy there? Also with, I keep thinking, the way the tags are naturally here and not there. In some cases, I know you have to type just to make it part of the standard, but is there any import routines?
So in terms of how we get data connected, so I'll reference here, if I were to add a new tag on this EasyLogix, that information would be dynamically published. So just by virtue of adding that tag and saying, yes, I want this to publish, that's all it takes to do that. Where this becomes powerful is that as I've created different lines here, see if I can get back to my line namespace. Yeah, it'll be easier to show earlier, so I apologize for all the screen clicks. So if I've done my equipment model, you can see here that I have lines 1. I guess I'm going to have to use my laser pointer again so that it can be seen. If I've done my data models right and I've mapped my overall asset tags correctly, creating lines 2 and 3 are just a matter of copying and pasting those lines because I parameterized. You notice here there's this thing called line number. Oddly enough, line 2 has that parameter of line number 2. So in terms of as I create new tags, how is that information presented? The idea is that if I've done this correctly, it's just by a matter of that intelligence is just created and it's now readily accessible through the rest of the enterprise.
So I guess I'm thinking more of on the edge situations where I've got a PLC and getting those tags up into your first instance of the smart system. And then on the other side, getting your tags into the MES system.
So in terms of getting, one of the hardest parts of doing this is that now I need to get my asset, my actual tags mapped into a corresponding tag into my IIoT platform. In this case, it's going to be Ignition. So there is some work that's associated with that. If the person that did the PLC programming followed a common naming convention, it makes it a lot easier to get that information back because then you can parameterize this. So a particular line that I was working in, their plastic extruder, they followed a naming convention for the OPC server that literally once I went to the other, there's 6 lines there. I did one of them. When I went to the other 5, it was literally just a matter of changing the address of the equipment itself. And that's how that was taken care of. It was then available to all other parts of it. So even in this case, I'm using Sepasoft for the MES because I'd also parameterized my equipment model in Sepasoft. I was actually able to, let's see, do I have a line? Yeah, right here at the end. So this line, UNS, because that's an equipment model, I have the equivalent function of Sepasoft because it's also parameterized, because what I've told it is go into my line 1 folder and then capture my line 1 tag. Actually, I call this line, pretend this 1 isn't here. I'm going to cover it up right now. I now have a line namespace that maps to those tags. So literally how everything gets consumed, if I've created my namespace correctly, it's now more readily accessible. It's a lot of work up front And this is that modeling at the edge is what it's the concept of model everything as quickly as you can so that now it's a lot more accessible by other systems.
You know, your Grant asked a very, very good leading question as to where I was going to go with a couple of sets of questions. Because you've made some statements about there's some work to do here when you're setting up and doing the architecting. And so, and Grant was going from how to update a legacy system or how to map this into a legacy system. If you're going to either you're going to add a new line, or you're going to add a new division to the company, and you want to begin using this kind of architecture.
Mhm.
Have you thought about where you're going to teach this, David, other than just what you're doing in your standard business development? Because E.J. Daigle, of course, is a dean and now an interim dean of engineering at Dunwoody College of Technology, and he's overseeing a new computer science program that is really still kind of IT focused.
Mhm.
I, along with some others, are trying to nudge them toward more OT. This might help explain to them how to do that. And then also how to build some curricula, because it would be a couple of different where to insert it, maybe in a PLC programming. Here is one way you could start thinking about doing your programming. How to make it more user effective in both from an architectural standpoint, as well as down to asset, equipment, function, and information that you want to get out of the system. And so I'm asking, I'll go back to the question, the leading question was, have you thought about how and where you're going to teach it? Because I think I would recommend you to EJ to help them put a program together.
So I am working with our local high school. I go in every year for our career day at our middle school. And I'm also talking to a local technical college around what are the things you need to know as an OT professional? And it's a pretty extensive list. It's not just programming languages 61131. I need to know SCADA. I need to know MES. I need to know ISA standards. I need to know databases. I need to know operating systems. There is a pile of stuff that you really need to know how to do. So that's where I'm getting it connected. That's where I'm getting plugged in. More than happy to teach these classes with people that so they understand how to do it, because yes, there's a lot of legacy out there. You need to create, there's a whole steps of how do you digitally transform inventory, the business inventory intelligence, connect all your data, build your unified namespace. That's where you start putting in all these semantic data models of what are my assets going to look like, what is my equipment going to look like, and then start getting into more of the functions and calculations that need to be done. So there's a methodology for doing these types of things. But coming up with those edge models, that's where there's a lot of work in doing that, because there's a lot of legacy data that's there. Create that model. So there's a product called HiByte. And they make the company is HiByte, their intelligence hub. That's exactly what it's designed to do. One of its first things that it does is actually get to a KEP server, to KEPware, and you can start creating those asset models. But once you
go ahead. Yeah.
So one of my questions would be, are we tagging stuff in the PLCs wrong right now? I mean, so if I'm looking at a system where I have 2 tanks, let's say, and I've got a number, using my Emerson example from our lab there, Tom,
Yep.
and I've got let's say a pump, and I've got a level, and I've got temperature, and I've got flow, and I've got all of these things on tank number 1, and I've got similar tags on tank number 2. Should I be tagging those as kind of like you mentioned in the previous example that you were looking at those plastic extruders or whatever it was? Should I be tagging those as, tank 1 temp, tank 1 flow, tank 1 this, tank 1 that? Should I be creating a UDT or something for tank 1 and just having all of those tags fall underneath the tank 1 UDT rather than having those be discrete tags?
Yeah, so you'll notice here that I have analog 0 through 7. I have inputs 0 through 7. Then I have discretes 0 through, I think, 29. But in this, how I'm actually utilizing that is that as I've created these SOCs, the alert primary variable and set point, one of them is an output, one of them is an input, and one of them is the discrete. I've actually created a parameter that corresponds to its number.
Gotcha.
Is how I've done that.
Gotcha. Nice.
Yeah, and it's once you look at it a couple of times, 3-4 times, you begin to see that it can help a programmer conceptualize what needs to get done, because the focus is to contextualize the data that you're going to get out of it.
Mhm.
And so you're kind of working almost from the end backwards, as a lot of, when you do a system, that's part of what the engineering is, right? You're looking at form, fit, and function. And when you're programming a system, you're looking at its function and you're going back to see how it's going to fit. And so it's this back and forth, but you're establishing more clarity as you're simplifying your programming. Really,
Mhm.
it really simplifies the programming, just like function blocks did.
It
to
kind of almost
PLC
reminds me. It kind of almost reminds me of, you go back to like an RS500 platform where all of the tags were predefined, right? So it didn't matter who programmed it. You knew what, timer1.acc meant. Well, nowadays people create arrays of tags and they call them whatever the hell they want.
Yeah.
And that becomes a little bit problematic. And sometimes they create, an array of 16 elements, and sometimes they create an array of, 4,000 elements or something like that. And it seems to make it messier as we've given the programmer more options to how they want to create their data, how they want to set up their arrays within the PLC.
So one of the adages is that we make no assumptions for how the data is going to be consumed. So, and that's very difficult. So yes, so data governance is becoming more and more popular of how do we actually ensure that, and enforce that when somebody is going to do a PLC program or a DCS program, this is one of the toughest things in all of programming and controls is naming. What are we going to call the thing?
Yes.
I ran into that of, EQ path. Okay, that's my equipment path. That one's pretty easy, but now I need to create a schedule list. Well, what's that? What's going to be called? Type of thing. So, that becomes challenging. There's legacy. Then there's how do we do the new things? And this is where you start bringing in the data governance. One thing I didn't really show you here, the idea was that here's how I'm securing the system, because I'm able to elevate data from lower levels into higher levels and doing it securely. That was the gist here. What I didn't show you is, bringing it all together. What does this actually look like, outside of this SOC, my filler nozzle that I didn't expand, but this is how I'm now getting all of those, bringing in that particular data. So this is a standard operating condition 0. I could have, really what I wanted to do was call those tags, something that was a little more semantic to where you could look at it. And then as I started consuming those tags, it made it a lot more easy to, turn that into, add context as it gets into higher and higher level systems.
And Dave, I hadn't asked this question earlier when I really wanted to, because you're talking about ISA 95. When you talk about HMI or HMIs, you're talking, I think, what is it, 88? As
HMIs are 101. Yeah, 88 is for
101.
batch control. Yeah.
Yeah. Okay. So you're talking standards.
Mhm.
Who created the UNS, and is there a standard behind it?
So there is
Or
no
not
standard.
yet? Okay.
Well, and so that becomes a very long, probably a longer conversation for this. It is our contention, within our side of the fence, and when I say professionally, I'm one of the, I'm a principal consultant for Spruik. We utilize ISA 95. That to us is that semantic data model. Now, what it doesn't cover are things like, say, your asset models. But once you get into your equipment models, your all of the, material models, your personnel models, your asset models, all of those types of things, those have already been predefined. So as far as we're concerned, the ISA 95 standard does give us, it's a standard that was developed for connecting our ERP into our control systems. And a UNS, for all intents and purposes, is how do we connect all of this data that exists in our OT layer and get it into our business system? So that's our contention.
And I see, oh, go ahead, finish up.
And I was just going to say, so that's ours, but you'll have others that it's going to vary from company to company based on how they operate their business.
Yeah.
And that's sort of that, there are some, it's a long conversation.
Yeah, and I can see where it would be modified depending on what your market space is.
Mhm.
What are you actually producing? Because somebody who's in a automating, you're automating an ability to create roof trusses, and you're automating a roof truss.
Mhm.
The UNS around the equipment and the functions and the lines and cells and whatever else of your automated factory is going to differ from a pharmaceutical company. So the whole UNS thing, right, is going to be modified, application specific. But
I think, yeah, go ahead. I'm sorry.
Okay, so where I was going with this is, do you see it changing the way we teach programming, both the computer science side as well as the PLC and the OT side? And where I'm coming again from this is this cyber-informed engineering dynamic that's trying to get rolled out from Idaho National Labs, where we need to try and start merging IT and OT training so that it's cyber-informed engineering, 100%. Whether you're engineering software or you're engineering hardware systems, or the integration of those two separate components.
Yeah, so within 61131, there are different languages you can use, function block, structured text.
Yep.
You got to know how to learn ladder. I swear, if you are a programmer, PLC programmer, and the first thing you do is, I'm going to do this in ladder, you should be just fired right away. Yep. Structured text with comments. That's what you should be doing, or function blocks, one of the two.
Here.
With comments. Yeah.
Yeah.
Those are
ever
the two
since
things
I was
you
at
should be doing.
Siemens, I've been promoting 61131. And now it's, what's the new term for it? There's another version of it. I saw it today and I can never keep it in my head. It's another European thrust, but it's effectively 61131 under another name.
To me, programming is a programmer. So I'm a big believer in CodeSys. Only because it's an open 611. There's 600 plus devices that all support it. I learned how to program one routine. I can now apply it to 600 different pieces of technology, assuming that they can all do that same type of thing. Opto, Wago, PLC Next. I can write the exact same controls narrative in one IDE, and I can use that. But there's a way to do structured text there that follows a lot of your same principles of how you program and do some things. So absolutely.
It's higher level programming brought down to the hardware level.
Mm-hmm. Yeah, absolutely. But what it means is that it's enforced. It's also it's checking to make sure that you're not going to do something dumb. I mean, your permissives are your permissives, but it's going to compile. It has to work. It seemed like, so going back to whether you're making roof trusses or pharmaceuticals, ISA 95, you can still create all your models in there. There's always going to be your equipment, your material, your assets, and your personnel, and you're always going to have request objects, you're going to have schedule objects, you're going to have response objects. All of those things exist, and you can absolutely publish that information back. So is there a standard for a UNS? No. Could ISA 95 be one of those? Yes. But there needs to be a better understanding of what ISA 95 is and does.
Okay, let's leave it at that. David, if you put your contact information up as one of the slides, if you've got a slide there. Our viewers, the viewers of this later who have questions for you, they can contact you if you're open to that, or if you want it to be somebody to come through, they can come through me or come through EJ. We'll leave Grant out of this because he's got other stuff.
All right.
But
So let me create another slide quickly that you can, I'll just plop it in.
so that sounds perfect.
All
So I
right.
still, for one instance, I still like ladder logic, and it's for a latching motor circuit. I just think that's just so elegant and more clear. Well, maybe just because I'm old, but more clear than like structured text to do motor control.
No doubt. No doubt.
Yeah.
I
I know,
can't disagree
I
with
do
that.
paint with a broad brush, but I've seen some ladder logic. It's like going, what on God's green earth are you doing here? You can't even follow it. You know,
Yeah.
there's a reason why ladder logic was created. It's because you had electricians that were doing
Yeah.
PLC programming. So, you know, I actually have done some ladder. Some of those examples were done using ladder. My motor control is actually a ladder program because it has that seal-in circuit where
Yeah.
once I hit the button and my my coil is hot, it seals it in because there's a reference tag to it. So yeah, I
awesome.
agree. But that all the programming that I have for all of my you know, when I wrote those tags, I created one subroutine in Opto, and then I just called it how many ever time for those instances. Done.
Yeah.
Right.
So
Very
anyway,
cool.
there's my contact information.
Yeah, it looks good. David, thank you so much. You spoke very quickly. It was clear. I have seen it a couple times, as you know. And so looking to help try to spread the word on this, because I think it's some very important stuff to do to, you know, as for digitalization of systems to both clarify, contextualize, and gain more meaningful data and understanding it better. So let's go out there and try and do that. And I'm sure EJ will be contacting you about you know, helping architect maybe a 3-course block.
Yeah, it'd be great. Be great.
More than happy to help put together what needs to get put together.
Love it.
And I'm with you on the education and teaching that. What you're going to find is that there's some of the incumbents are going to work against this because they're not. That's not how they do it. So
No.
just be aware of that.
Oh
Yeah,
yeah. That it can be earth shaking, or it can be just, we're going to creep into your backyard and we're going to plant a garden there, and you won't even realize it. It'll just spring up one day and it'll be there.
As I mentioned CodeSys earlier, it's slowly at first, then suddenly all at once.
Yeah.
So,
Hey, Tom.
All
Yes.
very great information. Thank you.
Yeah,
That's my
great
pleasure.
job,
Thank you.
David.